This is a very brief introduction to exercise 9.8 on integrating y equals to f dash x over f of x. There really is just the one rule that I've written in green that we need to focus on. That's really focus. We've done some integration by recognition in the past. We're going to continue doing that, and that's pretty much the next exercise as well. Okay? Integration by recognition, as I mentioned in the past, it's something that VCA loves to bring up, right? Either in SACs, hint, hint, nudge, nudge, or in exams as well. Okay, so something to think about. Integration by recognition is definitely a key skill you should know. It's one of the more complex ones given its abstract nature, but again, you should know how to do it. The formula that we're focusing on for this lesson is y equals to f dash of x over f of x. The way we should be using this is not to say that this is the formula we're using, therefore that's true, but rather, is this something that's applicable to our question? If so, then we can use that formula. Okay, of course, questions for this exercise, there's only a few. 9.8 only covers 9 questions, so there are only a few, but just keep that in mind moving forward. When we're anti-deriving the derivative over the original function dx, it equals to the natural logarithm, and you've seen me write natural logarithm. I'm going to stop writing log base e, okay? But just note, of course, natural logarithm, f of x plus c, for where f of x is greater than 0, reminder you, same as last lesson, the f of x must be greater than 0 for the domain of my natural logarithm. Just a quick reminder, if you're writing log, please make sure you write the base. Even if it's 10, log base 10. Make it very clear to your assessors. I've got 2 examples on the board, which are visible on the screen. They're both examples of either using this formula or integration by recognition, or a combination of both. Okay. The first example we're focusing on is this one here, where we have the antiderivative of negative 12 over 7 minus 3x squared dx. This question is asking to find, of course, the antiderivative. Okay. Now the first step is, and I recognize this because I know that the bottom function, when I derive it, because right now it's a parabola or a quadratic, if I derive it, it'll give me a linear equation, which in this case is the same as that one there. So while I might not get, when I derive the bottom function, get negative 12x, I might get something that I can manipulate to get that. And I'll explain that through the example I'm doing now. I'm going to say let y equal to 7 minus 3x squared. Can you read that up the back? I know it's quite small. Okay. I'm just going to derive it. dy dx equals to negative 6x without the square. Negative 6x. So it makes sense to say that this, so the answer, I should say, negative 12x over 7 minus 3x squared equals to, and I'm just going to write, and you know what, it might have been easy to use f, you know what, I'm going to replace this, you don't have to, I'm just going to replace this to make it a little bit easier to write. So f of x and f dash of x. Yeah, let's just make it easy to write. That means that f dash of x, which is negative 6x by the way, and to make them the same, I just times it by 2, and I'm going to keep f of x on the bottom, because that hasn't changed yet. If that's the case, and I'm going to do a dotted line and then just separate, it makes sense that when I'm anti-deriving this, right? So antiderivative of this is the same as, I'm just going to rewrite it here to make my life a bit easier. 7 minus 3x squared dx equals to, I'm going to take the 2 out to the front. So it's 2 antiderivative of f dash of x over f of x dx. So I'm going to repeat those steps again. I've let the bottom function be f of x. I've derived it, noted that it's a negative 6x, which isn't the negative 12x, but it's something I can change into negative 12x. I've equated the function given to me in the question to my new function, but of course I needed to multiply by 2, because it's a negative 6x instead of negative 12x. And then in order to apply that, I've just anti-derived it on both sides. Well, of course, e equals 2 times, and I'm just using this formula from above. The antiderivative of the derivative over the function itself is equal to ln of the function on the bottom, f of x, plus c. Any questions about that so far? Well, of course, I need to substitute it in, which means that's 2 log base n of, and I'm going to put the function on the bottom 7 minus 3x squared plus c. Now I am missing a small step. Does anyone know why that's not my final answer? Yeah.
You've got to say for f of x is greater than 0.
Great, perfect. So I need to say where, and I probably shouldn't encroach on the next question space, where, and I'm not going to write f of x, I'm going to write 7 minus 3x squared is greater than 0. Right? Because otherwise it would be implying that this applies, that this is correct for everything. Yes?
Could you put 7 minus 3x squared in the absolute and when it's still correct?
That would be correct. Thank you very much. Or 2 ln of 7 minus 3x squared. You know, I'll just put the absolute step brackets. Squared plus c. Now I want to make it very clear, I didn't cover that because it's not part of the study zone. Okay? You do not have to know this, but you will not lose marks if you do that. So this will suffice. Right? So this is just the process of anti-deriving. It's kind of a bit of a combination with recognition, integration by recognition, sorry. But to get to this step, you can say the derivative of the bottom looks to be the same power as the numerator. You think by now in Year 12 methods I would stop using bottom and just use the denominator at this stage. Are we happy to move on to the next section? Correct. The next component is more so anti-differentiation by recognition. It says find the derivative of ln x squared minus 5 and hence find this, right? Every time you see find the derivative, hence find this, it's integration by recognition. You should be, well, first finding the derivative and then figuring out in what way can we manipulate that to look like this. That's pretty much what we're looking for. Are we okay for me to erase this middle column just because I'm worried I want to run out of space? Okay. All right, let's first find the antiderivative, so the derivative of ln x squared minus 5 bracket. Just to be clear, for those of you that might be a little bit curious, you might see a question presented to you like this. Okay? It doesn't mean that it's being integrated. Now, when you're using your square brackets, when you're integrating, it is implied that it's integrated. But that's just an implication, right? So you can use square brackets outside of the integration process. So, finding the derivative of that, of course, it's going to give us the 1 over x squared minus 5, right? Because that's the derivative of our natural log. And then multiply, because it's chain rule, multiply the derivative of the inside, which is 2x, which gives us 2x over x squared minus 5. Oh, apologies, plus c. Again, because it's integration by recognition, you should recognize the fact that my final answer, 2x over x squared minus 5, should be a constant away, either by dilation, by reflection, by translation, some sort of transformation that doesn't involve an extra power. So, for example, if I had done this incorrectly, let's say I'm in the exam, I'm stressing, I do the derivative, and my answer is 1 over x squared minus 5. By recognition, it is impossible to get from 1 over x squared minus 5 to x over x squared minus 5 because of the difference in power. Okay, so that's just a step, a checklist, a checkpoint you should make sure that you get right. Okay, so we get to 2x over x squared minus 5. From here, I'm just going to write this in here, right? So I'm going to go antiderivative from 3 to 6, and because I'm putting in the numbers, no more plus c's. Of x over x squared minus 5 dx equals 2, right? Equals 2. From 3 to 6. So, I think I'm missing a 2, aren't I? I am missing a 2, aren't I? Thank you. Because this is 2x over x squared minus 5, which means that when I anti-derive this, because I'm saying the derivative of this is that, When I'm going backwards, I put this back in there, but that should give me half or double this one. Now, just to make that a little bit clearer, I'm going to rewrite that, okay? So I'm going to say that the derivative of this gives us this, right? So I'm saying, in other words, antiderivative of antiderivative of 2x over x squared minus 5 dx equals to ln of x squared minus 5. Okay? Now that's twice though, so I can actually take that 2 out and put it here, which is what this question's asking, right? Because this is x instead of the 2x, so we just brought it out to the front, 2. Okay? Or in other words, you can multiply that by half. Okay? So you should end up with 3, 6x over x squared minus 5 dx equals to a half of ln x squared minus 5 from 3 to 6. Thanks for bringing that up. I knew something was off. I had to double check. I'm going to try to write this along the bottom just because I'm running out of space. I do apologize. Actually, should I? Are you okay if I erase this side? Okay. So from there, we do our substitution. I end up with half of, and do this big brackets of ln 31 minus ln of 4. Closing the brackets again, right? Because that's just substituting my 6 and my 3. Now, again, because it's log laws, it's a reasonable simplification. We have to simplify it. That gives us half of ln of 31 over 4, which we can't simplify any further, so we leave it there. Make sure you don't make the same mistake I did, right? Remember that we have to transform in some way from 2x to x, right? By dividing by 2, so that we equate the two equations.